Alright, let's talk about the rotating the box. So you're given an n by n matrix. So for each cells, it can be number sign, or there's a star, or there's a dot. So each represent what? Stone, and obstacle, and empty. So what you have to do is you have to rotating your metric 90-degree right, and then clockwise, right, and then to this one. And if there is an obstacle, right, then basically this one has to free fall down to the obstacle, and this is pretty much it, right? So you rotate, so you'll free for this column, right? And then rest of it are the same. So the first thing is what? The first thing is um the first thing is you have to rotate. So when you rotate, you don't care about there's an obstacle or not. And then the second is going to check the free fall, right? Free fall. So if you see there's an obstacle, then you have to make sure the last available spot should be here, right? Imagine this is the obstacle, right? So this is a star. So let me just quickly just draw a diagram. So this is the diagram, the metric, right? And maybe this one more. So if this is the obstacle, right? The last variable should be r minus 1, right? And this is pretty much it, right? So when you free fall, right, you have to traverse your column first. So column will be the outer for loop, and the inner will be the rule. And just making sure you know, because you have to check the free fall first, right? And this is pretty much the solution. So what I will do is I will have to reinitialize my box to rotate, and later I will say free fall, and then I will pass in the box, right? And then I will return the box, right? And this is the basics function you need to implement. And let's talk about the published 2D array. I'm going to say rotate, char array. I'm going to say box, right? So I can actually reuse my box 2D array, but that would be too complicated. So I will have to have a initialize my 2D array to chart equal to new chart, and I need a length. I need a length of my box dot length, and also my width, and equal box 0 dot length. All right. So when you rotate, right, your column, the number of a column should be the number of row, right? The number of row should be the number of column, right? So it's going to be reversed. So this is going to be passing the n. This is going to pass in the n, right? And then I need to traverse. So I equal to 0, I less than n, I plus plus. For in j equal to 0, j less than n, j plus plus. And somehow I need to initialize my result to box ij, right? But in this case, we are actually adding the value based on the column and traverse the row, right? So you have a C, this will be represent column, and this one is actually represent the number of row minus 1. So you are starting from the last, right? So let me draw a diagram. So when you rotate, this is what? This is 0, 2, right? But when you want to input, is 2, 0, right? So you start from the last. And this might not be the best solution. Let me find out another example. So here is it. So just think about it. If this is what? If this is 0, 1, 2, 3, 0, 3, right? You need to rotate to what? 3, 3, 1, right? So you need to start from 3 and then go backwards, and then this will be what? This will be 1, 3. And when you reverse, right? This is what? This is 3, 0, right? So this is 1, this is 0, this is 0, this is 1. So basically, this is actually a math problem behind. And then you will have to decrement your column number, right? And the j will be represent r, and this is starting from 0. And yes, here we go. So I will pass in R and pass in the C in here. Now I get a rotated metric. Now I need to know how to write my freefall, right? Freefall, and I have passed in a 2D chart array. I'm going to pass in the box. All right, so I still need what? I still need n equal to box.length, m equal to box.0.length, and then I need to traverse. So in this case, I'm going to traverse my column first, right? So if I traverse my column, so this should be what? This should be 0. So if I use C, it would be better. So C, and then C less than column M, right? And then C plus plus. And then I will have a row. So row is starting from the starting from what? Starting from the last row, right? You're starting from the last row because the free flow is actually what? From top to bottom, right? So if you're starting from the top, you doesn't know what do you have in the bottom. So from the bottom up, right? So it's gonna be r minus 1, r greater equal to 0, and r minus minus. Now let's talk about the available space, the last available space, because we didn't know like which space we have from bottom up, right? So we need to making sure what is my last empty spot. So I would just say last spot will be a -1 just in case, and so I need to know my C. So box it R is C will be my character. So if C equal to a dot, so dots represent what? Empty. So I don't have to carry about it because my last empty will keep track of the dots, to be honest. And if C is actually equal to what? Obstacle start, right? Then I should know what the last available spot shouldn't be at this index, should be at r minus 1, right? So last empty will be r minus 1, right? And then I continue. So you can use continue or doesn't matter. So let me do something else. So I can say using else, right? Else if there's a star, right? And then I can say else if C equal to number sign. So if you see a number sign, you know this is a stone, right? So I can place a stone at the last empty spot. But when I place it at the last empty spot, I need to reinitialize the current stone cell to the dot. So because it's basically it's like swap, but not exactly sure. So RC equal to dot, right? But box last empty SC is equal to number sign. And then if you use this current space, you're going to decrement your last empty. So this will just keep track of the last empty, be honest, and without too many questions. Okay, I use this here again. So let's just say B, B, and B. Alright, so I need a return value. Okay, I'm making a mistake. And here we go. So let me submit. Yeah. So let's talk about the time and space. So in this the first rotating function, you need a space. So it's going to be all of n times n, right? And then the time is all of n times n, so the same. And the free for one, right? The space is constant, and time is all of m times n. So for each different function is different, but overall the time and space are all of m times n, and they are the same. So this is pretty much the solution. And if there's any question, leave a comment below, subscribe if you want it, and I will see you next time. Bye.